Power generation by solar and wind energy. Solar solar cells heat energy is the most sought energy for human beings to cook the food as well as to keep warm in cold climate. However, the use of wood as the fuel for fire has ended of in deforestation and resulted in drought. Search of fuels lead the main lead the main to use coal and then oil. However, commodities however these commodities are fast dwindling, and after few hundred years both may completely vanish from earth. As such, it is essential that human race should find alternative source of energy from nature. Hence, the use of natural resources like heat from sun through by several scientists, and one of the solution to the energy crisis is the invention of solar cell. The solar cell essential a large photodiode designed to operate solely as photovoltaic device and to give as much output power as possible. When these cells under the influence of light ray from sun, they give out about 100 milliwatt per centimeter square power. Construction and a cross section of typical powered solar cell pictures. 1. The top surface consists of extremely thin layer of p-type material through which light can penetrate off to the junction. Given the picture show symbols and construction light energy, this is the given pictures, and in these pictures solar cells. Light energy light energy uh, light energy this is the light energy. Solder's positive contact and nickel platings, p-type silicon p-type silicon p-n junction, n-type silicon nickel plating, and solder negative contact. And this is the load and direct of the whole flow, and direction of whole flow, direction of electron flow. Cross sectional area construction and cross section for solar cells. The nickel plated ring around the p-type material is the positive output terminal, and the bottom plating is the the native the negative output terminals. Commercial produced solar cells will be available in flat strip from for efficient coverage of available surface area. The circuit symbol of solar cell is shown in pictures 1. According to different manufacturing standards, the output power varies from 50 milliwatt per centimeter square to 125 milliwatt per centimeter square, as shown in pictures 2. The graph picture 2 shows the characteristic of solar cell, which gives so milliwatts per centimeter square. Considering the characteristics curve, it is apparent that the cells will deliver an output current of 15 milliamperes. When the output terminals are short circuit, the output voltage will be 0. On the other hand, open circuit voltage of the cell will 0.55 millivolt, but the output current is 0. Therefore, again the output power is 0. For maximum output power, the device must be operated at the knee of the characteristics. In solar cell, the output power decreases at high temperature. Typical output characteristics of power photocell for use as solar energy converter. Picture 2 given that a maximum power point and output current 125 मिलीवाट पर सेंटीमीटर, 100 मिलीवाट पर सेंटीमीटर्स एंड 1 ओम 50 मिलीवाट पर सेंटीमीटर्स, 200 मिलीवाट, 15 मिलीवाट, 10 मिलीवाट, 5 मिलीवाट और 100 ओम्स. The output voltage given that output voltage, and this is the given that output current. Output characteristics of a power photo cells use a solar energy converter. Array of solar cells connected as a battery charger. Picture 3 shows a group of series parallel connected solar cell operating as battery charger. Several cells must be series connected to produce the required output voltage, and number of parallel groups to be provided as per the required output current. This is the 18 parallel groups, and this is the 13 series connected cells, and this is the battery, an array of solar cells connected as a battery charger. Example: a village welfare club having a black and white TV which operate at 24 volts taking a current of 3 ampere for 4 hours. Normally, an array of solar cells are used for charging the 24 volts batteries in the light source from sun available to energize the cells from about 10 hours a day. Calculate the total number of solar cell of 125 milliwatt per centimeter square required and the series parallel grouping of cells. Solution refers pictures to. As per the graph, the solar cell energy converter should be operated at approximately 0.45 and 57 milliampere. Assuming the charging voltage should be higher than battery voltage of 24 volt, the solar cell should supply 26.4 volts for charging the battery circuit. Number of series connected cells, output voltage 26.4 volt, cell voltage 0.45 volts is equal to 58.5, said at 59 cells. The charge taken by the battery after every day of TV programs will be 3 amps in 4 hours, 12 ampere hours. This should be supplied by solar cell in 10 hours. Hence the ampere requirements. Ampere current is 12 ampere hours, thus 1.2 amperes. The total number of group of cell in parallel, output current 1.2 amperes and cell current 57 milliampere. Say that 21 cells, the total number of cells required, the number of cell in series into number of group in parallel. 59 into 21 is equal to 239 cells. Solar energy generation. The solar energy, very large exhaustible source of energy. The power from the sun intercepted by the earth is approximately 1.8 into 1011 megawatt, which is mainly thousand of times large than the present consumption rate on the earth of all commercial energy sources. Thus, the principal solar energy could supply all present and futures energy needs to world on continuous basis. This make it one of the most promising of the non-conventional energy source. In adding to its size, the solar energy has two other factors in its favor. Firstly, unlike fossil fuels and nuclear power, it is environmental clean source of energy. Secondly, it is free and available in acute quantities in almost all parts of the world where the people live. However, there are many problems associated with its use. The main problem is that it is a dilute source of energy. Even the hottest region of the earth, the solar radiation flux available rarely exceed 1 kilowatt per meter square, which is a low value of technological utilization. Consequently, a large collection area are required in many applications, and this result in excessive cost. Solar electricity, when Sunlight strikes on photovoltaic solar panel, the electricity is produced. The method of generating the electrical energy from the solar panel cells is termed as solar energy generation. The generation of electricity by using a solar energy depends on the photovoltaic effect in some specific material. There are certain materials that produce electrical energy when these are exposed to direct sunlight. This effect is seen the combination of two thin layers of semiconductor materials. One layer of this combination will have a duplicate number of electrons. When sunlight strikes on this layer, it absorbs the photons of sunlight ray, and consequently the electrons are ejected and jump to the other layer. The phenomena create a charge difference between the layer and resulting to teeny potential difference between them. The unit of such combination of two layers of semiconductor material for producing electrical potential difference in sunlight is called solar cell. Silicon is normally used as solar cell. For building cells, silicon material is cut into very thin wafers. Some of these wafers are doped with impurities. Then both doped and undoped wafers are sandwiched together to build solar cell. A metallic strip is attached to extreme layer to collect current. The desired number of solar cells are connected together in both parallel and series to form a solar module for producing a desired electricity. The solar cell can also work in cloudy weather as well as is moonlight, but the rate of production of electricity low as and depends of intensity of incident light ray. Pictures 4 describe the typical system of solar panel, controller energy, storage inverter or converting DC into AC, and how the system is connected to power grid. Pictures 4 is given that this is the power grid and circuit breaker connected, three-phase line, filter and transformer, and connected inverter DC AC and DC links and solar panels. This is the circuit breaker is connected of fiber optics, and this is the connector connected of controls room, and this is the connected of fiber optics, then control board and communication, and the fiber optics and connected inverter DC AC, and controls rooms is connected fiber optics and three phase line, filter and transformer. This is the picture and solar power plant. Solar panel installation norms. Solar modules must have some industry standard known as the standard test silicon test condition STC. It is a set of conditions to test a model, mainly include this factor and irradiance and sunlight intensity. It is the amount of sunlight falling on plane surface. Its unit in watt per square meter. The measurement standard is unit 1000 kilowatt per meter square. Air mass, it is the thickness and clarity of air through which the sunlight passes to reach models. Its standard is 1.5. Cell temperature, it is the testing temperature at 250 degrees centigrade. Modules efficiency, it is the ratio of output power to the input power is called module's efficiency. Module uses the photons in the sunlight to produce a DC electricity. Normally, 1000 watt per meter square of sunlight strike 1 square meter area of module. If a 100 watt of power is produced from that square meter, then the module efficiency is 10%. If it is 50 watt power is produced from the square meter. It has an efficiency of 5%. For efficiency cell, it must have the flowing key factor. It must have a high short circuit current. The open circuit voltage is also must be high for obtaining the above possible character, with possible condition must be fulfilled. By choosing low band gap material to get high value of short circuit current and high open circuit voltage, assembling and installation of solar panel. A panel is able to function using the solar energy which is derived from the sun. The solar panel installed on the rooftop absorbs sunlight, photons from the sun, silicons, and the conductors in use for solar panel converts the sunlight into a direct current. DC electricity flow into the inverter. It is an renewable energy. The process of converting sunlight to electrical energy and more efficient than other process. Solar panels contains many different silicon cells. Yeah, solar cells. The energy derived from the sun connected into electricity with the help of solar panels. The solar panel installed on the rooftop absorbs sunlight from the sun. The sunlight and the conductor in the panel convert to the sunlight into DC flow into the inverter. The inverter then converts DC to AC, which can be used at homes. Excess electricity that is not used can be fed back to the grid when the solar panel produce less power than required at home. The process of connecting solar panel to electricity. Solar panels is used to a special process of connecting protons to electrons to generator generate a current by making use of a special type of cell known as a photovoltaic cell. These cells are commonly found on the front of a calculation, and a small gadget are connected together called as solar panels. Photovoltaic cells are made of semiconductors materials such as silicon, which absorbs the light from the sun. The photons is the sunlight current, the electron within the sunlight. Basic idea of solar modules: array and balance of system, BOS. तो मॉड्यूल्स में हम पढ़ते हैं मॉड्यूल्स. द सोलर सेल्स आर made in various shapes and size. The smallest of the cells can be seen in a device like an ordinary calculator. These type of device are very little amount of power used in home lighting system. Needs are more power to run on. The number of cells are put together to produce more power. The group of cell is packaged together in enclosed space is called as modules. It helps to give higher voltage, higher power, and protect the panel from rain, snow, and wind. Etc. Voltage and power output modules depend on the size and number of cells used. So more number of modules are to be connected in a simple assemble of modules is known as array. Pictures given have five. This is a cells and this is a modules, and this is a array, this is a array, and this is a panels. Cells, modules, panel and array systems. Balance system जिसको बोलते हैं BOS. The cells, modules and array are the power producing part. A small device like radio needs a small amount of power, can be directly connected to a small modules, but most of the device appliances need more power at night. The assembly of modules, battery and appliances is simple. From a PV system, a modules cannot be connected directly to battery, so a charge control on charge regulator is used in a battery. Between modules and battery and inverter are required to operate AC appliances. so the whole system is packed. The modules is known as a balance of system BOS. Given a picture 6, the given a picture 6 a computers 80 watts SK एम 995 मेंस 200 सप्लाई से इन्वर्टर 150 वाट्स एंड दिस इज the solar panels 55 watts and this is the inverters connected of battery 120 hour amperes and then the battery is connected to charge controllers 12 volts charge controllers and charge controller to connected to uh, solar panel 55 watts इसी को बोलते हैं BOS चार्ज कंट्रोलर को ही बोलते हैं BOS. The main component in BOS assembly are storage battery, charge controller, inverter, and support structure, junction box, wire cables and fuses, connection and switches, and the function of the above component and explained briefly below. Storage battery, the most small system used for lighting in only 12 volts. For longer system like refrigerator 22 24 volt is used if they help to keep the wire size small and system losses to a minimum. It needs to handle carefully. It must not be overcharged or fully charged to prevent from damage. The current मतलब कि charge controller, the if the battery is not able to control charge on its own, this work is done by a simple automatic device known as a charge controller in the following way. It seems the battery charge and switches off the charging current and avoid from a damage. The disconnected the appliances when the battery charge goes below a set limit. That prevents reserves current and protects from short circuit. Inverter. Inverters, a solar system produce only DC power, but home appliances need to AC power. The device examples CFL is required for this purpose to convert DC into AC is called as inverter. Support structures. The solar modules cannot be simply placed either on ground or roof. It needs to call the sunshine at angles to keep the module safe from any strong wind. Support structure is used for solar PV system. Junction box, it is a meeting a point for many where this may be from a row of modules or from modules to battery bank. A junction box is made of an unbreakable materials, polycarbonate. It makes use of copper connected for a high current flow. It protects the system from moisture. Wire and fuses. These solar systems carry a low voltage but high current, so the large diameter wire is needed. Fuse keep the solar equipment safe against the short circuit. CFL यानी compact fluorescent lamp. It is not only energy saving lamp but also having long life 8000 hours and less heat output. Common available CFL are 5 वाट 235 ल्यूमेंस एंड 7 वाट 370 ल्यूमेंस 9 वाट 600 ल्यूमेंस 11 वाट 900 ल्यूमेंस and the solar panels are installed from some application like solar power plant, solar lantern, solar lighting system, and solar water pumping system, solar battery charging system, solar hybrid system, and solar grid connected power plant, solar home system, solar water heater, etc. For an example, the procedures installation of a solar home system is explained below. Given a 7 so below block diagram of solar panel install. Collect the system from the packing. Given below pictures This is PB array and charge controller, and the charge converter connected to battery, battery to inverter connected to battery, and inverters connected to DC load, and inverters connected to AC load. Then block diagrams of solar power system. The check from the any damage for outright on the different parts of system. Connected the load injection box controller. Connect all lighting loads charge control to load junction box with the interconnecting cables. Place the charge controller on the box. Keep the battery inside. Fire models on the support structure. Vote the system appliers box layout. Mounting of charge controller. Mount the controller to wall into screw that fit to the wall material. Connected the battery cable assembly with fuse supplied along with the controller. Connected first controller and then battery and two modules. Connected the wire to load and only then to controller. Electrical connection connected the battery to the system only after getting fully charged. Do not switch on charge the load for 2 and 3 days when the battery is on fully charged. Connected the AD cables to charge control with connect polarity. Keep the switch off position and connected to the load cable and battery cable to charge controller. Switch on the load and lamps for the normal operation. Test the solar panel installation for its function. Pictures 8 and B show the installed solar panel with mid clamp and with frame mounted installation are illustrated. And functionality of solar panel. The sunlight is the basic fuel of solar panel. Sunshine is the cues to keep the panel for normal functioning, but the environments around the modules with effect is its working. Given a pictures 8e and the mid clamp illustratel. Given a pictures 8, this is a mid clamp illustratel, and pictures 8b, this is installed solar panels with frame illustratel. And the following few factors will affect its normal working cues for power loss, tilt angle, dust, shading, and this is shading after light intensity, temperature, charge controller after semiconductor energy loss, cabling losses, improper connection, tilt angles. The solar's model must be installed the proper path of sun and it is tilted properly at angle the equal to the latitude of the place. If any error in the tilt angle will lead to same amount of the power loss. Dust it is modules is not cleaned properly. Dust will form on modules surface in the dry season and it may cause for high energy loss 5 to 10%. Shading solar modules face the sun all day. Their shaded should not be present on it. In such a place only it must be put up, but due to extended free transformer, TV antennas etc may use to present sets. A solar modules are made of string of individual solar cells and connected in series with one another. Suppose and as an example, one cell from 36 cells in a modules in fully shaded. The power output from the modules will become 0 due to high resistance, but if one cell is 50% shaded, then the power output is reduced to 50% only of a high resistance. Light intensity, the more power is produced from the panel is bright sunlight from 1000 watt per meter square of sunlight, the rated output power will be full. But if it is a 50 watt meter square only, rated power output will be half. The output power is directly proportional with the increasing of solar in insolation. Temperature: the higher the temperature, the output power is reduced from a modules due to power loss. It is tested at standard temperature at 25 degrees Celsius. During the bright sunlight, cells may reach 30, मतलब कि reach 70 degrees Celsius also. If crystalline silicon increase from 0.4 to 0.5% per degree temperature, increase above 25 degrees centigrade amorphous silicon's module's temperature coefficient is 0.2 to 0.25% per degree of temperature increase. Charge controller: if the charger controller is continuous operation and draw a small current of above 5 milliampere to 25 milliampere, then the power loss is around 1%. Semiconductors energy loss: the charge controller is having the component as a MOSFET and blocking diodes, which is used for heat energy loss. Cabling loss means the cable are also used from power loss. It can be minimized by choosing a large diameter of wire size. Improper connection: if the electrical connection are not made properly, it results in less power feed to the battery. It can be reduced by keeping clean and tight connection. This is the wind power generation. This is the wind power generation. The methods of generating electrical energy by using the wind is termed as wind power generation. Since the wind has velocity and kinetic energy, it can be used to produce electricity. For that, we can use windmills. The important part of windmill, it is structured with large level leaves fixed at the top of high tower. The speed of leaves change with the speed of the wind. If the rotation of the windmill is given to the rotor of generator, then the electricity will be obtained from the generator. If the windmill is connected to water pump, the leaves of the windmill rotate the pump and pumping out of the water. Wind power can be useful exploited for the generation of electricity, as there are large coastal hill and desert area. Wind turbines comprising of machines with blade diameter of 17 meters, which can generate about 100 kilowatts, strike a blowing wind or specially designed blades of a windmill rotor cues both to rotate. This rotation, which the mechanical energy when coupled to turbine, drive the power generation. Operation: the schematic arrangement of wind power station is given pictures 1. So this is the given ISU generators and ISU grids, internal consumer, and this is a connected of grid, and this is a gearbox, and feed again connected brake, and again connected to generator, rectifier unit, and line converter unit, and generator is connected to exciter, and rectifier is connected to chopper, and this is the connected of turbine controller. This is the wind power generation. Wind the When the wind strike the rotor blades they started and blades start Rotating rotor is directly connected to high speed gearbox convert to rotor rotation into high speed which rotates the electrical generator. An exciter is needed to give the required excitation to the coil so that it can generate required voltage. The exciter current is controlled by turbine controller which senses the wind speed. Based on that it calculates the power what we can achieve at that particular wind speed. Output voltage of electrical generator is given to a rectifier and rectifier output is given to line converter into a stabilized to output AC that is fed to grid by high voltage transformer. An extra unit is used to give the power to internal auxiliaries of wind turbine like motor, battery, etc. This is called a internal supply unit. ISU can take the power from grid as well as from wind. Chopper is used to dissipate extra energy from the rectifier unit RU for safety purpose. Advantage: the wind energy is free, exhaustible, and does not need to transportation. Wind power plant, on the other hand, does not to take long time to construct. Such windmills will be highly desirable and economical to the rural area which are far away from the exciting grids. There is a strong reason why wind power should be welcome to grid which have some hydroelectricity input in India. The water level in the hydel reservoir is at its lowest before the onset of the southwest monsoon. If less water is drawn during the monsoon, as high level could be maintained for longer period during the monsoon period, wind energy can be used to feed the grid. It is non-polluting. It does not require high technology. Electricity can be produced at a lower cost after installation. Disadvantage: the major disadvantage associated in the wind power is that is not constant and steady, which make the complications designing the whole plant. And the rotor blades of wind turbine generator must sweep out large area to produce worthwhile amount of power. The wind is very dangerous. Such storms can use tremendous shear stress which may spoil the whole plant within no time. To avoid this, special and costly design and controllers are always required. Among all disadvantages maintained above, the cost factor is the major which has restricted the development of wind power on a large scale for feeding to exciting grid. The estimate cost of wind electricity generation storage distribution system over 1 lakh rupees which may be considered beyond the means of most India village. Modern wind machine are still wrestling with problem of what do when the wind is not blowing. A large turbine are connected to utility power network. Some other type of generator pick up the load when there is no wind. Small turbines are often connected to diesel electric generators. Yeah, sometimes have a battery to store the extra energy they collect when the wind is blowing hard. The wind energy is utilized by means of windmill or series of windmills. A windmill consists of few vanes, normally 3 to 6, which rotate about their axis when the wind blows against them. The rotational motion, I mechanical energy, thus the create is utilized for various applications such as lifting water from the well, battery charging, water pumping, operating a simple machines. Wind energy used agriculture and rural applications such as grinding floors, mills, wood cutting saw, stone crushes, mixers, water pumps, and irrigation facilities, etc.